Let me find my calculator. All right, so in Y1, I'm going to put my function. I've got a bunch of stuff in mine because we've been doing calculus. All right, so I have alpha y equals x to the third. Nope, I got 3. Okay. Third minus 14x minus 27 over x plus 2. And then I'm going to put 3 in the other window. And I'm just going to zoom 6. I don't know what my thing's like that. Okay, so how many times do they intersect? Just once. So second trace, we're going to choose number 5. Okay, yours is going to say first curve, second curve, guess. All right, mine says you got to get close to it. And so our intersection 4.875. Okay, looking for x. So we would write g of x is equal to 3 is what we're finding. X is equal to 4.875. You want to put x equals. It's what you're solving for. Okay, but that's totally calculator. Okay. All right, part 2. Okay. Typically, we'll ask you something about end behavior or asymptotes, something like that, okay? It's going to switch around a little bit. It says determine the end behavior of G as X decreases without bound. So let's think about that. As X decreases without bound, is that my left end behavior or my right? Left, okay? If you write both, you will not get the point. All right, because they're checking, do you understand which side we're talking about, okay? So we're talking about the limit as x approaches negative infinity of g of x. That's what we're trying to find, okay? And notice it says use a limit. So you have to write it that way. We're going the left end behavior because x is decreasing, all right? It means left. Now, let's think for a second, all right, about end behavior. We know that we're going to take the highest degree term of the numerator, which is x to the third, over the highest degree term of the denominator, which is x, and we're going to reduce. Okay? When I reduce that, what does it reduce to? X squared. What does an x squared function look like? Yeah, it's a U. It's a parabola. Look like you're about to direct music there, Wilmer. Okay, it's a parabola. So which way does it point on the left? Points up. So we would say positive infinity. That's what we're looking at. Okay, so we write down what's happening top to bottom, you know, left and right. We reduce, and that's what we get. Okay, we're good with that. Okay, then we get to see, it is always a modeling type question, right? If they give us a table, it's going to be a modeling type question. And so it says use the tables of values of f of x to determine if f is best modeled by linear, quadratic, exponential, or log. Okay, so let's just take a second and think through those. All of those, all right, except for log. Okay, all of those except for log, the x's have to increase at equal intervals, do they? Yes, okay, they increase at equal intervals. So we know it's not going to be log because that one has to be proportional. What's up? Did you leave your stuff? You were just so excited to get out. Just playing. Bye. Okay, so we know that one's good. Let's check the y values. How are they changing? Okay, if it's exponential, we're multiplying by something to get to the next one. Are we doing that? No. Okay, because -5 times, you know, at 4 times something to get 7, we're not multiplying by something, so it can't be exponential. So my options are linear or quadratic. Okay, so if it's linear, these differences are all going to be the same. Okay, so let's see. 34 minus 17 would give me 17. 17 minus 4 would give me 13. 4 minus a -5 would give me 9. So it's definitely not linear. Which one does it have to be? It's quadratic, okay? So we would say a quadratic model is best. On the next one, we explain why. Okay, so they split them up, and I don't know why they did that. Okay, but they split them into two parts. In the first one, you just have to state which model. In the second part, we have to say why. Now, oh, it's not that serious.
I was wondering if I could take those missing quizzes.
Yes. How'd the show go?
It was okay. It was okay. That's what I'll say.
Okay. I'm not going to get to come tonight. I'm so heartbroken.
Really?
Yes, I got work.
Are you gonna see tomorrow?
No,
No.
I gotta teach. Just call me a loser. Okay. You want to just do them on this paper, you have to put them in, and I'll write them. Make it easier for you. Did you cook noodles? I keep smelling food. I'm like, I'm starving. Okay. All right, now we didn't finish the explanation, all right? Well, we didn't finish doing our math here, but if I did negative 5 minus negative 10, that would just be what, 5? Okay. So if it's quadratic, what's going to be true about these values? We know the first time it's not linear because they're not equal, all right? But if I do it again, what's 9 minus 5? 4. And 13 minus 9. And 17 minus 13. 4. What did we call that again? The second difference. So that's where the y is going to come in on the next part. Okay? The next part says, okay, you picked quadratic. Now tell me why. Okay? And we would see. All right? We would say this. Quadratic is best because, right? And this is important. Over equal length inputs, all right, meaning our x's are equally spaced, okay? The second difference in the outputs is constant, okay? So that's what they're going to be looking for, all right? They're looking for all those crazy words, right? Quadratic is best because equal length inputs, they're going to look for that. Second difference in the outputs, all right, is constant. And they're very specific in that grading. And I'll be honest with you, grades last year in terms of point values awarded on the free response were very low globally, all right? So like on one of them, our average for the points that we got as a group was like 0.7, but the global average was like 0.4. So we were way ahead, okay? So they are grading them hard, all right? So just as a heads up, they are grading them hard, okay? All right, so that's question 1. Non-contextual, math, knowing the math, okay? Question 2, you got to apply it, okay? So it's going to be in some kind of context, all right? And it's going to look trickier than it probably is, all right? 1, because there's too many words. All right, so here we go. Students who completed the class participated in a year-long study to see how much content from the class they retained over the following year. At the end of the class, students completed an initial test to determine the group's content knowledge. At that time, equal to 0, the group of students achieved a score of 75 out of 100. For the next 12 months, the group was evaluated at the end of each month to track their retention. After 3 months, their score was 70.84. Now, I want to tell you what I get out of all of those words. I get 2 ordered pairs. At 0, they made a 75, and at 12, they made a 70.84, okay? That's what I see in all of what I just read right there, okay? You need to look for some math. There's going to be something in there that you're probably going to need, okay? Oh, not 12, after 3 months. Sorry, I wrote that down wrong. Okay, so T equals 3, 70.84, T equals 0, 75. Okay, then it goes on to tell me some other things. It says that the group's score can be modeled by the function R given by. If they give me a function, I'm going to need it. Okay, I'm going to need it. where R of T is the score in points for a month T, and T is the number of months since the initial test, okay? Use the given data to write two equations that could be used to find the constants A and B in the expression for R and T. Here's why those two ordered pairs were important, okay? This is T, this is R of T, right? What we're going to do is we're going to plug those ordered pairs into that equation they gave me, and that's it, okay? It just wants me to plug them in, all right? So let's do the first one. At time 0, R of T is 75 equals A plus B natural log of 0 plus 1. Okay, if it makes you feel better, you could say 75 equals A plus B ln of 1. Oh, my brother's on his way to Nashville today. Oh, I'm so excited. He's going to get his girls from school tomorrow. Okay, then we're going to do it again. He goes, I'm on my way to Top Hall Catfish. Bless him. Okay, let's do the second equation. Our second R is 70.84. It's going to equal A plus B natural log, T was 3 plus 1, or 70.84 A plus B natural log of 4. Okay, that's all it wants you to do. It gives you a quadratic model. It doesn't matter what model they give you. Almost always in this first question, we're going to plug in ordered pairs and write equations. Okay, so that's all it wants. Okay, all right. Now, calculator active. Okay, it's a calculator active problem. So it says, now, smarty pants, that you wrote the equations, let's find the values for A and B. And this is where it gets a little tricky. Okay, this is where the math is going to math on you. All right, look at this first equation. 75 equals A plus B times the natural log of 1. Okay, now, if you don't remember about natural logs, okay, there is an LN button on your calculator, and this is a calculator active question. All right, what's the natural log of 1? It's 0. We can just type it in, it's 0. Okay, so what's going to happen to that B term? It's gone. What's A? 75. So we got one of them down. Okay. To find B, we're going to plug that value in for A. And so I've got 75 equals, no, that's not what I wanted. Hold on. I'm going to do the second equation because I already used that one. All right. 70.84 is going to equal 75 plus B times the natural log of 4. We want to solve for B. What would I do? Subtract 75. I have no idea what I get. It's going to equal B times the natural log of 4. And then how would I get B by itself? Yeah, divide by the natural log of 4. I got negative 3.001. Double check me though, y'all know I lie. Okay. So A, you're gonna have to write a system probably and solve it. All right, and it may be a tougher system, but it can be done. Okay, they're gonna give you a way to get an answer, which is nice. All right, they're gonna give you a way to get an answer. Okay. All right, let's look at the next part. So that's part A, some kind of equation calculation, okay? Then they're going to talk to you about average rate of change because we did rate of change with everything we did, okay? And it says use the given data to find the average rate of change in the test scores in the points per month from T equals 0 to T equals 3. Express your answer as a decimal, show your computation, okay? So you can't just put an answer, all right? How do I do average rate of change? Remember, average rate of change is just slope, okay? So we're going from 0 to 3. So I want R at 3 minus R at 0 over 3 minus 0. Well, lucky for us, they gave us those values. Okay, those were those ordered pairs that they gave me to start with. Okay, so 70.84 minus 75 over 3, and we're just going to get that approximation. Okay, now this is in context, which means we have to have units. Okay, so the top one is talking about my score. That represents the points that I earn. What do the T values represent? They're measured in what? Months. So it's going to be points per month. Am I gaining points or losing points? I'm losing points. The more months I go, the more points I'm going to lose. Okay? And the reason I ask that, because that's what they want you to do in Part B, is explain what you just found. Okay? What does that rate of change, or Part 2, what does that rate of change represent? It means that on average, the score decreases, right, because it's negative, by 1.387 points per month. Okay, notice that I didn't put decreases by negative. Okay, that would be like a double negative in a sentence. We wouldn't want to say that. If we say decreases, we leave it 1.387. If we say increases, we leave it if it's increasing. Okay, so if it's positive, you say increasing, leave it positive. If it's negative, decreasing, leave it positive. Okay, so the score is going to decrease. So they want you to compute something, that's not a word. They want you to compute something and then explain what it is, all right, when it's context, right? Then we get to Part 3, okay, or Part 3 and Part B. All right, so it says consider the average rates of change of R from T equals 3 to T equals P months. So we don't know how many, okay, where P is greater than 3. Are the average rates of change less than or greater than the average rate of change from T equals 0 to T equals 3 months found in Part I, or Part 1? Explain your reasoning, okay? Now, let's just think about this for a second, all right? Let's think about this for a second. We found A and B, right? We found our equation to be R of T equals 75 minus 3.001 ln of T plus 1. Okay, so that was our equation. When we found A and B, that was what fits this model. Okay. Now, we got to think for a second about a logarithmic function. All right, about a logarithmic function. Typical logarithmic function looks something like this. All right, so if I was just doing a regular ln, it would look something like that. Okay. Now, ours has that 75 on it, so we've scooted it up a little bit, all right? Plus 1, we've scooted it back a little bit. But this negative in front is going to do what to that natural log? It's going to flip it. So that negative natural log is going to look more like this, okay? The only way, okay, so our equation is going to look more like that. The only way to determine if I have an over or an underestimate is by concavity, okay? Is by concavity. When I look at this one, now that I know which way it's going to go as an ln, is it concave up or concave down? The red one. It's concave up, okay? And anytime it's concave up, we have an under approximation, okay? And it also means that if I'm concave up, my rate of change is increasing, okay? So concave up means that I have the rate of change is increasing. So this is about really knowing the math, okay? So here's what we would say, all right? We got to take all of that we figured out and we got to explain what we think, all right? And answer the question. Are the average rate of change less than or greater than? Okay, so we would say because R of T is logarithmic, okay, and it's a decreasing logarithm, okay, and decreasing, the graph is concave up. All right, so we have to say how we know what's happening, okay? Therefore, the rates of change are increasing. Over equal length inputs. Okay. So I personally feel like of question 2, the last part of B and part C are the toughest. Okay, they will always be the toughest parts, but we can get some of those earlier points. All right. I'm not saying you might not get on the test and have a brain sparkle when it comes to this one, right? I mean, that might just happen. Okay, but you might get a little bit in there and do better than you think. Okay, write something down. Don't write Mary had a little lamb, IDK, call my mama. Like, just don't do any of that. Okay, put something mathematical down. You might get something. Okay, so that's important. Last part, all right, of this one. Okay. The leaders of the study decide to use a model R to make predictions about the group's score beyond that 12 months. Okay. So for a given year, model R is an appropriate model if the group's predicted score at the end of the year is at least 1 point lower than the group's predicted score at the end of the previous year. Okay. Based on this information, for how many years is model R an appropriate model? Give a reason for your answer. It says, note that the end of the year occurs every 12 months from the initial evaluation. Okay, so basically what it's saying to me, if we're thinking months, all right, if the result at month 12 and the result from month 24, so year 2, year 1, has to be greater than or equal to 1, right? So if it's at least 1 point lower than their predicted score, all right? Likewise, the next year, R at 36 minus R at 24. We're trying to check, are they differences greater than or equal to 1? Right? So we would just keep checking them, all right? So we would use our model, all right, that we found, all right? So our R was 75 minus 3.001 ln t plus 1, okay? I'm going to do this on my calculator, and I'm just going to check them, okay? Because if it works for the first time, then I'm going to check it for the next year. Then I'm going to check it for the next year, all right? When does it stop working? Okay, so I'm going to go over here to my calculator, and here's a trick I want to show you, all right? And y equals, I'm going to put that equation we wrote. Okay, 75 minus 3.001 ln of x plus 1. Okay, I don't care about the graph because I'm going to look at the values of the function. Okay, so 75 minus 3.001 ln x plus 1. Okay, I'm going to go back to the home screen. All right, and clear what's there. To get y1 and use it, okay, alpha trace y1, and I'm going to plug in 24, minus alpha trace y1, oh, I forgot my minus, okay, y1, and then I'm going to plug in, oh, not that, alpha trace y1, 24, minus alpha trace y1 of 12. Okay, and I'm going to get an answer. All right, negative 1.96. Absolute value of that will be greater than 1. That year's good. Okay, we're going to do it for the next year. Hit enter, and I'm just going to change the numbers inside. 36. Why is GHS calling me? Hello? I do. Yes. Thanks. Bye. Hey, Parker, Mr. Anderson wants to see you. I don't know.
It's a weird way to get in touch with me.
I know.
Sir.
I don't think you're in trouble, but I was just like, okay.
I'll be back.
Okay. It's all good. The room, yeah, I was like, it was sweet Miss Alice from downstairs. Okay, I was like, why is GHS calling me? I'm like, I'm sitting right here. Okay, anyway, I'm not skipping. So again, it's good. It's greater than 1. We're good. And then we could do it one more time. And then change that. So do you see what I'm doing? I'm just checking. Okay. That's not what I wanted. So go over here. Delete, delete. And this time we would do 48. And over here we would do 36. Delete, delete. Okay, so it was at that third year that it switched, right? Because it would be less than 1 because it went to 0.84. All right? So this year was good. That one was good. But when we got to year 4, it messed up. Okay, so year 4 was where it didn't hold true. All right, so we would say year 4 is the first year. The model is not appropriate. Because we already said R is a decreasing logarithmic function, so R is decreasing and concave up. Okay, so I don't want you to stress too hard, all right, about those, okay? I don't want you to stress too hard, especially when we go to those last points. Okay?
Can we have some color back?
It's all right there, baby. Okay. All right, so what I want to do now is I want to do the 2024 problems, all right, 1 and 2. So these are the ones that they had last year, okay? So we'll actually see these, okay? So this is legit, a free response question, okay? And I want you to notice how similar it is to what we just did, okay? Which is nice. If you do enough practice of these, you're going to get better at them, okay? All right, so for that first one, all right, so you're welcome. Here's my function. It gives me f up there, and then it gives me g down here, okay? And it wants me in that first part, A part 1, to find g of f of x and give me the value of h at 3, okay? So I'm going to jump down here and let's do that, okay? So for AI, I want h of 3, which is g of f of 3. We're going to do some computation, okay? We start on the inside. F at 3 is going to come from the graph. In other words, we just want the y value when f is 3. What's that y value? 1. Okay? And then because it's calculator active, we're going to take 1 and plug it in for g up there. All right. And I think you get 2.041. Okay. If I had to guess, I would guess my kids got that point. Okay, they don't let me see specifically which points they got. They just let me see the averages. Okay, so I would think we got that one. All right. Now, part 2. Find all the values of x for which f of x is equal to 1, okay, or indicate there are no such values. So we're looking for where f of x is equal to 1. That means on this graph, what are the x values where it crosses at 1? How many times does it happen? It happens 3. Happens 1, 2, and 3. What are the x values where they happen? Okay, at x equals -3, 0, and 3. Okay? We literally just had to draw the line on the graph. Okay? So that's nice. They used the graph instead of the function this time, so we didn't have to do the calculator. Okay? So that was part A. Part B. All right, I find all the values of x as approximations for which g of x equals 2. So this time I'm going to need the calculator. Okay, we're going to do the intersection. We're going to find where is g of x equal 2. So we're going to put g and y1. And then the other one, the 2.96.7 to the x in y2. And we're going to get that decimal approximation. I think it crosses once. Okay. Right, at 1.057. Okay. All right, then on part 2. Determine the end behavior of g as x increases without bounds. So is that left or right? Right. We're going to increase, so we're going to go to the right. We want to use the notation of a limit. So I know I'm going to start there. The limit as x approaches positive infinity of g of x. And so now I have to think about my g function. Okay? Is it exponential growth or exponential decay? It is decay. Why is it decay? Yeah, we got a fraction inside of there, okay? So it is exponential decay, okay? Now, we have to remember with an exponential function, okay, it doesn't decay to infinity. Does it decay towards? 0, okay? It decays towards 0, so, or your asymptote, so it would be 0, okay? So that's what they were looking for on that one. Okay. All right. Part C. Okay, so CI. So again, it's going to ask me about different things. Notice it's asking me about an inverse. Okay. Determine if F has an inverse. Okay. So let's look. All right. We're going from negative 3.5 to 3.5. In order to have an inverse, it would have to pass a horizontal line test. Does it? Okay, horizontal. I mean, it fails right here at y equals 1 because how many times did 1 cross it? 3. Okay, we can't say that in our justification. All right, what does horizontal line test? It's that test if it's 1-to-1. Okay, and it's not. Okay, so that's what we have to remember. We use horizontal line test, but we can't say it. Which is weird. They don't want you to use it because it's not an official mathematical term, okay? And so it says, does it have an inverse? We're going to say no. F does not have an inverse. On the domain negative 3.5 to 3.5, okay? Because that's what it gives me. First thing it says, does it have an inverse? No. Okay, you can't just put no, all right? Say the sentence. They just want you to have good math, all right? Part 2, however, is where we have to tell it why, okay? Give a reason, right? The easiest reason would be this. The function f is not 1-to-1. On negative 3.5 to 3.5. Okay, that's the easiest way to say it. All right. It's just not 1-to-1. It does. Okay. If it does have an inverse, we would say because the function is 1-to-1. All right. So we think horizontal line test, but we say 1-to-1. Okay. So horizontal line test, we would say 1-to-1. Just as a reminder. Okay? All right, so I knew we wouldn't have enough time. So we're not going to finish, all right? So keep all the stuff you picked up, okay? We'll work on that some more Thursday. We've also got time going into Monday, all right? So tomorrow you'll get to look at that. If you want to look at the practice questions, all the keys and stuff are on for today. So if you wanted to go ahead and look ahead at those other 2 free response questions in preparation to take the rest of the test tomorrow, you're welcome to do so, okay? If you think it might help you a little bit, okay? But then we will continue and finish all this, all right? Good job.